In this video, we are going to have a look at the transformation of graph, which is a pretty advanced topic at GCSE, and we are going to try and understand why things work the way they do. So in this first video, we are going to have a look at the addition. So let's have a look at these two functions, f of x and g of x. So the first way to combine them is to write them as f of g of x. You will get x plus 3 squared minus 2 x plus 3, because you apply the function f to g of x, which is x plus 3. If you combine functions the other way, you will get x squared minus 2x plus 3. This is here f of x plus 3, where the first one was f of x plus 3. So you see that in the first one, you're adding 3 to the x, and here you're adding 3 to the f of x. Let's use value tables here to try and understand how this is going to affect the graph of f. To do so, we are going to use the value tables that we have here. The first one has already been completed. You have values of x from minus 4 to 4. And here we've worked out the values of f of x. So we have the values for this function. You can see that the first point can be checked on the graph will be minus 2, 8. And so it's this point right here. You see the x coordinate is minus 2 and the y coordinate is 8. The next one is minus 1, 3. So x is minus 1 and y is 3, etc., etc. So the curve we have here has been drawn from the values here in this value table. So let's now try and find out about the graph of f of x plus 3. So we need to work out the value of the function for x plus 3. So we are going to fill in this row before to say that for each value of x, what is the corresponding value of x plus 3. So we are going to get minus 1, 0, 1, 2, 3, 4, etc., etc. And now we need to work out the value of this thing here. Well, you see that if x plus 3 here, for example, is minus 1, if you want to work out minus 1 squared minus 2 times minus 1, it's actually the exact same calculation as the one you've completed right here. When x was minus 1, you did minus 1 squared minus 2 times minus 1. Okay, the only difference is that here, this calculation happens when x is minus 4, meaning that this x plus 3 is minus 1. Okay, so the value we find here is the value we worked out right there. So we see that all we need to do now is just copy the corresponding values from our table. We don't need to know what we have there. And now that we've understood this, let's try and actually plot the graph corresponding to these value tables. So the first point corresponding to this x coordinate will have a y coordinate equal to the value of the function when x is minus 4. And be careful, x was minus 4, x plus 3 was minus 1, and this is what we used to work out this 3, but this is not the value of x. The value of x is indeed the minus 4 that we have at the top. So let's plot this point with coordinates minus 4 here and 3. So our point should be right there. You see that before that, the corresponding point on our graph was this one here on the graph of f, and it was at minus 1, 3. It was at minus 1, 3. It was right here. The second one has y coordinate equal to 0 and corresponds to x is minus 3. So when x is minus 3, y is 0, you end up here, and the corresponding point on the first graph was actually 0, 0. We've used this value right there. So this was the original point on the curve. Well, now you should understand that, from this point we end up here, and we have more points here and there corresponding to these two. So if we plot the graph of our curve, we are going to end up with something like this. You basically see that every single point here has been moved 3 units to the right. So this explains why the graph of f is translated 3 units to the left, sorry, not to the right, when you are actually adding 3 to x. So this is quite remarkable because you would expect actually the graph to move to the right if you adding 3, but you can check actually looking at these value tables that it's the opposite here that is going to happen. Let's now have a look at the other graph, the graph of f of x plus 3 when you add the 3 to f of x and not to x. Well, to work out the value of this thing here, of f of x plus x when x is minus 4, well, you can just check the value of f of x, which was given here and has been reported right there, and you just need to add 3. So let's fill in this value table for f of x plus 3. Well, you know that when x is minus 4, f of x is 24. So f of x plus 3 will be 24 plus 3, it will be 27. And you can continue adding 3 to these values, following the same reasoning, to get the corresponding y coordinates on the graph. So let's start by plotting, let's say, this one, which is going to fit on the graph. You see that x is minus 1 and y is 6. So x being minus 1 and y is 6 give you this point. And you can see that our point that was originally minus 1, 3, right here, is now minus 1, 6, right there. So our point has been moved up 3 units. If you continue with the second value here, x is 0 and y is 3, so your point is right there. Once again, the original point 0, 0 has been moved up 3 units. And the same thing is going to happen for all the other points on our graph, meaning that the parabola that you get in the end is the black parabola that's been moved up 3 units. Okay, so if you add 3 to f of x, the graph moves up 3 units, as you would expect. But if you add 3 to x, instead of moving the graph in the positive direction from left to right, you're moving it in the other direction. So you need to be careful, because here is a trap. Just keep in mind that if you add 3 on the inside, things go the reverse way. So I hope this little video helped you actually grasp a little bit what was going on when we were adding 3 to x here, or f of x. Check the next video if you want to learn about multiplying x or f of x by a number.